Hi, so we are back talking about the Guild Agents SDK. Today we are looking at the auto-managed state agent, and we'll get right into it. You might wonder why you're using the auto-managed state agent. Well, a few reasons. If you can see your workflow, your agent doing something that's pretty much sequential, like calling a tool, inspecting the results, calling the next tool, and then returning some outputs. This is a reason why you might choose the auto-managed state agent over the other agent types. Another one is you want precise control over the inputs and outputs. So with every auto-managed state agent, you'll have this input schema and an output schema, and this will have precise inputs and precise outputs. The other reason is you want more deterministic behavior. You don't want your LLM deciding the control flow and executing things. You want more precision and more determinism. And if you recall our LLM agent from the last video, it's the traditional agent loop where you have a LLM controlling the execution flow. It calls a tool, that tool outputs some results, and then it goes in a loop until it outputs something to the user. And the problem, as we saw with the last agent, is that that's non-deterministic. So if you are inputting, like we did last time, an email into some agent that's supposed to be emailing people, then you could find yourself in a situation where that agent emails the wrong email address, and you don't want that. So how do we make an auto-managed state agent? You start with this use agent directive at the very start of your TypeScript file. That will tell Guild that to compile this agent into a resumable state machine. So that will be very helpful if the agent is interrupted for a tool call or some very long-running task. You will define an asynchronous run function, which will start executing. And for each await in that asynchronous run function, it's going to ask, is this a runtime managed tool, UI, or sub-agent call, anything that's going to suspend the agent for a while? And if not, it'll just continue, execute your promises, resume as normal. If not, you will suspend state and you will save. It will be serialized. It will do that tool work. It will do whatever it needs to do, and then deserialize. It will resume after that await and then continue running through the function until it returns some output. So simple as that. Let's take a look at our new and improved issue emailer from the last video. So as you can see, we have our use agent directive up here. We're inputting our tools. As we saw the pick tool previously. Note this task right here. We'll talk about that in a moment. So we are writing in my email here in this variable, this constant right here, and then the sender email constant as well. And here's our schemas. So precise inputs, precise outputs. Here I'd like you to take note of this tools type right here. This is essentially being used in our run function right here to basically add our tools to this task object, which I'll speak about this task object right here for a moment. This is what will allow you to interact with Guild. It'll allow you to basically work with services that will call Guild endpoints. So UI notify, as we saw in the last video, will allow you to speak to users through the platform. So that's very helpful to have. You need this task object, and making this tool, this type of tools right here will help you call these tools through the task object. So continuing, you see we have our agent logic in here. I won't go too deep into the weeds of how this works, but it is far more deterministic now. And so for each time it sends an email, this will be deterministic. It will deterministically call or send an email to this email address we've defined up here. There are some limitations of the auto-managed state agent. At the time of the recording, you cannot use promise all or promise any, promise race. Parallel tool calls will have to use a self-managed state agent. So we'll cover that in the next video. This may change. It may be subject to change soon, but for now, these won't be able to be called, but you can just sequentially call tools if that works for you. You also won't have dynamic function references. Not a huge sacrifice, but it may be something you want, and that might be a reason to use the self-managed state agent.